If you're a slide counter, we're just going to get through this part, okay?
Yeah, let's go.
Yay, let's let's do it. On Friday, remember, we kind of looked at, I love shorthand chemical equations representing chemical reactions. You know that a chemical reaction has occurred if you have new things formed. So, of course, R is reactants and P is products. And the thing I put up here on the board was water, electrolysis of water, electricity, and it breaks down into H2O gas and oxygen gas. Remember, hydrogen and oxygen are the diatomic elements, so that's why I have to put little 2's there. And I put an L here. And we said that was unbalanced. And then I went through the sort of deal where if we put a 2 here, okay, and we put a 2 here, thank you for the H2, then it's balanced, okay? So both unbalanced and balanced equations are awesome. Balanced equations give you quantitative information. It's like a recipe, and actually on Monday, or this is Monday, on Wednesday we're actually going to look at it as a recipe, and we're going to do some calculations with the balanced equation. But we're just going to talk about how do you get these set of stoichiometric coefficients. So I'm going to put a squiggly mark under all of the coefficients. Now there's a couple ways to do it. We're just going to talk about by inspection. So while I'm thinking about it, if you have to balance an equation, I would probably use a pencil. If you're a pen sort of person, you might find yourself kind of scratching things out. So these boxes represent where stoichiometric coefficients are. So I'll put up the first unbalanced equation. So you guys told me on Friday, if there is no number, it's implied 1. So when I went and put coefficients here, this is a 2, and a big 1, okay? One of the things you cannot do is change the species. You cannot change actually these subscripts, what it is that are the reactants and the products. So this isn't balanced, but if I do this set of coefficients, now I would do coefficient of, I would say the set is 1, 6, and 4. 1, 6, and 4. That actually balances it. And let's just kind of do a quick check. It looks like this, where this is kind of my brick wall, and on either side of the reaction I have phosphoruses and chlorines. Phosphorus and chlorines, this is my little tally. So my phosphoruses, I'm liking 4 over here because of that. And for my chlorines, it's 6 times 2. I'm liking 12 for my chlorines. Over here, I have to distribute this 4 to the P and this 4 to the 3 Cl's. So I'm liking 4 for phosphoruses and 12 for chlorines. So that's what we mean when we say it's balanced. But the thing is, you just have to come up with that set of stoichiometric coefficients that makes it balanced. Okay. Here's the unbalanced equation. This is just the combustion of methane. Of course, CH4 and O2 are the reactants. The products are CO2 and H2O. If we go with coefficients of 1, 2, 1, and 2 across the board, it's balanced. Okay. Let me do this as an example of, you can have actually, it's not an alternate universe, but you can have actually an alternate set of stoichiometric coefficients. So for instance, if I went with, I took everything times 2, okay, that means I end up with, instead of 1, I have 2 here, okay, oops, I'll put it up here. Instead of 1, I have 2 here. Instead of 2, I have what, 4? And instead of 1, I have 2 here. And instead of 2, I have 4 here. So that in green actually is another set. Okay, it's just basically scaling it up. Let's do a quick check and make sure that if we go with coefficients of 2, 4, 2, and 4, we have the same number of atoms of each type of element. So what we're balancing here looks like carbons, hydrogens, and oxygens. Okay, carbons, hydrogens, and oxygens. So down here, looks like with regard to carbons, if this is a 2, it looks like I have what, 2 carbons? Put 2 there. If we're going with a 2, with regard to how many hydrogens do I have? If there's a 2 here, I have 8. I'm liking that. How about oxygens? How many oxygens do I have if I go with a 4? I also have 8, yep. Let's go on the product side. Let's see, carbons. How many carbons do I have if this is a 2? 2. Okay, how many hydrogens do I have if this is a 4? I have 8. That's lining up. Now, this is an example of a situation where, notice we have oxygen in 2 places. And that makes life a little more interesting. We're going to have to actually add both of those up. So how many oxygens here with, if I go with a 2 in front of the CO2, how many oxygens there? So I heard 4. I have 4 there, and then how many do I have over here?
4.
I also have 4. Okay, so yeah, we have 8, 8, and 2. So it's balanced. So I used to, when I was first teaching this, say, no, you have to have the lowest set of stoichiometric coefficients. But now I'm kind of like, no, whatever you want to do. So this one, okay, this is an unbalanced equation. Now we talked about ionic compounds already. So actually, when I go to balance one of these, when I have an example coming up, you're going to see me, you don't have to, but I am going to keep the SO4 2- together. Because check this out, it stays as a unit. This is what we call an exchange reaction, and it's as a unit over here. You don't have to do that, but you can, and it makes life a little easier. Then similarly, you might recognize the OH minus. Okay, so I would keep that together. Bottom line, the set of stoichiometric coefficients go like this: 1, 6, 2, and 3. And I'm not going to go through that, but it really would balance the same number of aluminum, sulfurs, oxygens, sodiums, and hydrogens on either side of the reaction arrow. Okay, so when you balance it, like you're going to, I was looking at the homework that's due today, it's like, or do the homework at the end of this part, I'm like, oh my gosh, they get to do all that balancing? Woo. Okay, so when you balance them, then you actually give number information, quantitative information, in addition to qualitative information. So when I kind of put my hands up like this, kind of like this, not like this, but like this, kind of, okay. So there's a reaction arrow between them, so we have reactants over here and products over here. And we have to have the same number of atoms of each type of element on both sides of the reaction arrow. And I guess I don't say it, I must have said it earlier, but when you do that, you are like setting the universe right, okay? You're saying whatever atoms you start with need to be reflected in the atoms that you end with. Okay, no new atoms of different types of elements are formed. Mass is conserved, atoms are conserved. So I have some kind of visuals to go along with this. If you were to count the carbons, hydrogens, and oxygens on both sides, they would not be balanced with coefficients of 1 across the board. And this is kind of what it looks like. Of course, the black is the carbon, the whites are the hydrogen, and the reds are the oxygens here. Okay? So just visually speaking, again, if we go with coefficients of 1, it's not balanced. Let's see, to me, what it looks like, the reds are out of whack, the blacks are good, and the whites are out of whack. Okay, so it's an unbalanced equation. So now, if we balance it, it looks like this. Notice instead of coefficients of 1 in front of the O2 and the H2O, we put a 2 there. And visually, this is what it looks like. So now we have 2 sets of red O2s. And we have 2 sets of the Mickey Mouse looking water molecules. So now it is balanced. Now our red atoms, our oxygen atoms, came into line with 4 on each side. And also our white atoms, which are hydrogen atoms, came into line. So it's balanced. But like I said, see, this looks like I need to have a little squiggly mark there showing you. The reason I put little squiggly marks where that stoichiometric coefficient goes is to kind of hit myself over the head with it and anybody else who is doing the balancing, that's where the number goes to balance it. You cannot mess with the subscripts. Okay, we aren't making up new chemistry here. And this one doesn't work. My little animation doesn't work. But notice that. Let's just do a quick check. Here's my brick wall. I have phosphoruses and chlorines. Phosphoruses and chlorines. Looks like I've got 4 phosphoruses over here and 6 times 2. 12 chlorines here. Didn't we just do this one? This, okay. It's like, wow, that feels familiar. Okay. It's balanced. So this one's balanced too. This actually, and I have a still image of, this is what you guys did. Didn't you guys take magnesium ribbon and, yeah, oxidize it? Okay, good. This is what you guys did. It kind of looked like that. JC said to hurry. I'm just kidding. I'm just kidding. Okay. So yeah, this is what I said a minute ago. When you come up with those coefficients to give you the same atoms of each type of element to start with and to end with, you are applying the conservation principle. Conservation of matter, conservation of mass. And these are, again, to emphasize the word ordinary, these are ordinary chemical reactions in which you don't create any new elements. I'd say that's on my bucket list, but no, that's not even on my bucket list. I don't want to do any sort of nuclear chemistry. I'm fine. Okay, so let's see how we do this then. Like the whole trial and error thing is the whole use the pencil if you want to. Okay, in fact, some people who usually use pens on your test, you might want to grab a pencil and use it for this part. But it's kind of a back and forth sort of process. This is to say that sometimes you come up with coefficients and you got to go back and change them later, okay, until you're done. So you can't change any subscripts. You can only change where the squiggly mark is, where the big number to the left of the species, okay? And when you do that, you are changing the number of repeating units, or number of times you have that unit. Okay. Are you ready for an example? They're kind of fun. So this is the first one we're going to do, and you're going to kind of see how I go back and forth. So I'm going to go ahead and do my little break between reactants and products, and I'm going to start my tally. Fe equals, H equals, O equals. Fe equals, H equals, O equals. And then I go with how many there are with coefficients of 1. So coefficients of 1 leave me with 1 iron, 2 hydrogens, 1 oxygen. On the product side, I have 3 irons, 2 hydrogens, and 4 oxygens. So I'm going to put an asterisk next to the thing to kind of leave for last. So this right here, I'm going to leave it for last. And actually, hydrogen also falls in that category to leave it for last. Where the asterisks are, those are what we call elements. They're in their uncombined form. Elements uncombined. Leave for last. All right. So I'm going to leave my iron for last. So let's fix the oxygens first, shall we? So it looks like I have 4 oxygens on the product side. How do I get 4 oxygens on the reactant side? Yep, you guys are right. Put a 4 there. And if I put a 4 there, now I need to update my hydrogens, my oxygens. So here's my update. Looks like now I have, what, 8 hydrogens and 4 oxygens now, which is great for my oxygens, not so great for my hydrogens. So let's see, how do I get 8 hydrogens on the product side?
Put a 6.
do I get?
No.
I've got
4.
8. Put a 4? Okay. Yeah.
No.
We'll put a big 4 there, and that will give me 8. Yep. So as far as, and sometimes they go out of balance during the process, but now it's looking pretty good. My hydrogens and my oxygens are set. Now I don't have the right number of irons on the reactant side, so how do I get 3 irons over here? Just a 3. So does this make sense why I left my iron till last? Because I'm like, it's kind of like, it's easy just to kind of change it on the fly. So that's it. That's balanced with 4, 3, 1, and 4. Okay. So that's just doing it by inspection. Some are easier than others. Okay. All right. Another one? All right. So actually, in the last unit of material, we talked about the sulfate is SO4 2-, and the OH is hydroxide ion. And like I said before, I'm going to keep those as their own little entities. So this is kind of, you wouldn't have to, but I think it makes it easier. So here's my brick wall, and I'm going to go aluminums, and I'm going to go SO4s, and I'm not even going to put the charge there. I'm just going to say aluminums and SO4s. I'm going to go sodiums, and I'm going to go OHs. Oh, I can't do that. I'm going to have sodium 2-, or excuse me, sulfate 2-, and hydroxide -1. So then I'll put that on the other side too. Aluminum, SO4 2-, NAs, and OH minuses. So aluminums, it's looking like we start out with 2. Sulfates, if we have coefficients of 1 across the board, I'm looking at 3. Sodiums looks like 1, and OHs over here looks like 1. And then aluminums on the product side looks like 1. Sulfates on the product side looks like 1. Sodiums on the product side looks like 2. And hydroxides on the product side looks like 3. Cool. Then I go get a cup of coffee. So I don't have anything necessarily to leave till last. So I kind of start with what seems maybe the most complicated. These sulfates kind of look annoying, so I'm going to fix my sulfates first. I have 3 over here. How do I get 3 over here? Yep, just put a 3 there. So here goes my 3 here. Now I need to update my NAs and my SO3s. So updating my NAs, it looks like now instead of 2, I have 6. And now my sulfates, I have 3, which is wonderful. Then let's go for the hydroxides, shall we? Okay, so I have 3 over here, and I can get 3 on the reactant side if I put a 3 in front of my NaOH, right? I'll go ahead and do that. Now I need to update my sodiums. So now my sodiums, I've got 3. And update my hydroxides. Now I've got 3 there. Well, so far, I got my hydroxides and my sulfates are set. Sulfates and my hydroxides. Sodiums, they're still not right. Let's go for aluminums next, shall we? Aluminums, I've got, and you wouldn't have to do it in this order. I've got 2 aluminums here. Let's see, to get 2 aluminums here, I've got to put a 2 there. I'm going to go ahead and do that. Put a 2 there, and now I need to update. So that gives me my 2 aluminums. Now that messed up my hydroxides. So instead of 3 hydroxides, how many hydroxides do I have? 6, yep, I have 6, so I have to update this to a 6. Like, dude, I had that fixed. So it's not fixed anymore. All right. Let's go ahead and fix the hydroxides then, shall we? So if I do go with 6 hydroxides here, how do I get 6 hydroxides over here?
Put a 2 on the OH.
I have to change that 3 to a 6. Does that make sense? So this is the back and forth. Remember, this is why you use a pencil. I'm going to make that a 6. Okay, so now, once I do that as 6 to get my hydroxides to balance, let's go ahead and update the sodiums and the hydroxides. So the sodiums are updated. Now we got 6. The hydroxides are updated. We also got 6. And we're all done. Yeah.
Some that are bigger just have more steps included to get the.
Yep. Just have to be patient and kind of go back and forth, you know, and some are harder than others. Yep. Exactly. So now I did it with keeping the SO4 2 minuses and the hydroxides together. You could have broken them up and you would have gotten the same thing. But I think that was a little easier. Okay? All right. So one more example. So remember a little bit ago when I put the star next to the Fe and the star next to the H2? Keep those till last. That's what this is. That's what this is saying. Okay. Now this is kind of like one we looked at before, where if you look at things to balance, when it comes to oxygens, we have oxygens in 2 things on the product side. So that can make life a little interesting. So let's go ahead and start down balancing it. Start our tally. Carbons equal, hydrogens equal, oxygens equal on both sides. Now you don't have to, I'm really into showing your work, but you don't have to show your work like this if you don't want to, but you sure can. Okay? So starting out with coefficients of 1 across the board, I got 4 carbons, 10 hydrogens, 2 oxygens on the reactant side. On the product side, I have 1 carbon, 2 hydrogens, and how many oxygens? On the product side. I got 3. Very good. So things to keep till last, something in its elemental uncombined form, all I got is oxygen. So I'll keep that till last. Cup of coffee. So I'm going to go ahead and fix my carbons first. So if I have 4 carbons on the reactant side and I want 4 carbons on the product side, I can do that by just putting a 4 here, right? If I put a 4 there, I need to update my carbons that are now 4. And now how many oxygens do I have? 9. Yep. Very good. I've got 9. I've got 8 here and 1 here. Cool. All right. So let's go ahead and fix the hydrogens. So it looks like I've got 10 here on the reactant side. To get 10 on the product side, how can I get 10 on the product side? How do I get 10 hydrogens? If I put a 5 in front of there, yep. So let's update. So that gave me the 10 hydrogens. And now how many oxygens do I have? Feel free to use a calculator. 8 plus 5. Yeah, 13. I'm telling you, I use a calculator for something like that. Cool. So if we're keeping track right now, we have carbons look great, 4 and 4. Hydrogens look great, 10 and 10. But now the oxygen, we have 13 on the product side. We need 13 on the reactant side. The problem with the whole 13 on the reactant side is they come in groups of 2s. Okay, so 13. Yeah, what's that?
So, nothing plus anything is
So we need 13 though. So there's a couple ways to work this, and I'm just going to show you the way I would work it. I would think of, and in Wednesday's lecture this will make more sense, but I would think of these coefficients as moles of molecules. And so actually I can have, it's possible to have a 1/2 of a mole of O2. So with that in mind, if I go 13 halves, if I go 13 halves of O2s, I get, in my own mind, kind of 13 individual oxygen atoms. I know, it's a stretch, but it works. Okay, 13, and these come in, like I said, pairs. So that actually, a coefficient of 13 halves updates this to a 13. And then you have the same on either side of the reaction arrow. So if you're like me, though, the 13 halves, I'm a little unsettled with that. So if you are like me, then you can actually scale it up like I kind of showed you a minute ago. If you want to get rid of that half, that 2 in the denominator, if we multiply everything by 2, then that goes away. So an alternate set of coefficients, we multiply by 2, looks like this. 1 times 2, of course, is 2. What's 13 halves times 2? 13, yep. Yep, 13 halves times 2. Yep. So let's see, and of course 4 times 2 is 8. 5 times 2 is 10. So in green there, an alternate set of stoichiometric coefficients of 2, 13, 8, and 10 are great also.
So you will take the 13 halves?
Yes, I can take 13 halves also, yep. But the whole kind of halvesies only works, I think, because it's a diatomic element.
Yeah.
So, yeah. Yep. So either one of those. But I think this is neat how we're just kind of scaling, and it is kind of like a recipe. And Wednesday I'm going to very much relate it to recipe. We're basically doubling everything here, and we get double stuff back. It's a factor of 2. And it checks out either way. So yeah, fractional coefficients are okay as long as you kind of think of something, think of them as moles, relative moles, and we'll talk more about that on Wednesday. So this is the homework that's due. Now while I'm thinking of it, I just this morning updated the e-companion site for this class, and now on the home page, in addition to the Twitter feed, kind of in that middle section, is a, it's called a chemical reaction or chemical equation calculator. So basically what it is you can go there and you can type in what you want to balance and hit continue, and it will balance it for you. Now I'm not saying that's what you should do for your homework, but I'm just saying it's out there. It's a Wolfram alpha thing. So this is what these look like. And actually there are some hints here. I'm gonna, if I remember, and I think I will push these out because in some cases they give you the chemical reaction in words, and I kind of want to make sure we're all doing the same chemical reaction. So I'm going to push this out. Is that right? 6? Yeah. Okay. To balance a chemical equation, adjust the. Oh yeah. So what's the first word? To balance equations, adjust the blank. Stoich. If you just put stoichiometric coefficients. Yep. Never adjust the blank. What's that?
Subscript.
Never adjust the subscripts. Yep. Very good. Oh, come back here. Wrong button. Okay. Only does what you tell it to do. Here we go. Yep. So that's the first one. So this was the one, now 48, so like I said, I will push this out there on Twitter in case you want some help with this. But it gives it to you in words, and this is what it looks like in words. So basically, come up with the coefficients for the CO2, the H2O, the C6H12O6, and the O2. And I gave hints for some of these. Now, some of these hints are just kind of silly because you don't really need the hints. All I did in green there was to start the tally for you. That's it. So, yeah, CO2 plus H2O goes to form C6H12O6 and O2. On a test, I won't necessarily give it to you. I'll give it to you in the equation. So, I'll take all the fun out of it. So this is what this one looks like. Again, you can use that Wolfram Alpha thing to check your homework if you want to. Every once in a while, I'll go to balance an equation, and I'm like, this, I don't think it can be done. So, and I started the tally for the last one. Okay, this one, very similar. This one, very similar. Like I said, there's a lot, right? But it'll be good practice, and you definitely know you're going to have some of these on the test. And then one more page. Yep. I think that's it. Okay? Awesome. We'll see you tomorrow. And don't forget, I think you guys have done half of your classes, done this class review thing. So good. The evaluation survey, yeah. But if you haven't done it, do it. So it looks like we have cupcakes on Friday. See if we can get 100%.